So in our study area, we've long worried about what are going to be the impacts as water allocation and supplies may change throughout the state in terms of the soil and water salinity throughout the state. And so here a few years back, we started to do some inventories of the major river basins throughout the state in terms of the overall salinity. I just wanted to kind of cover with you the example of what the results of that, the potential for that is, and then talk about what we hope to continue to do throughout the rest of the basins throughout the state. So this is just of the Bear River system in Cache County. This is the first one we undertook, and the idea was to get a baseline inventory of salinity conditions throughout that basin area and look at specific fields as well within it. We ended up with 35 cooperators throughout that area, covering about a little over 1,500 acres. 30 of those sites we used as calibration sites, and then 5 back in for validation, so that we could look at verify that we were getting accurate depiction and maps of salinity throughout the basin. We're using remote sensing equipment to obtain those salinity measurements. We're using electromagnetics, electromagnetic induction devices to do that, and we can read bulk soil conductivity down to about a meter and a half or so in the soil profile. And then, of course, we're geolocating all of these measurements as we go through the field so that we can create maps of salinity on individual fields and then use those that data to cover more regional scale maps. So when we go into a field, we can take spot measurements for calibration, or we can hook it up to a sled like this and tow it over the soil surface, and you see in a pivot here the design of how the measurements are taken in more of a square field or rectangular field area, a similar kind of sampling arrangement, so that we can get high numbers of samples so that we can create detailed maps. We do take calibration samples in each of these fields, and they are evaluated for salinity directly so that we can create a model that will help us determine the salinity in those areas. What we end up with is a map of conditions in individual fields. This is a good example of that, where we can see the bulk conductivity as it's changing. The darker colors are those of higher saline areas. Within a field, lighter colors are lower in salinity. And then we can go back through and take spatial averages of individual fields, and they become spot measurements for more of a regional a map of the area. And so what we end up with is doing careful calibration of the measured points in each of these individual fields, and correlate those to the readings. We get really good correlations, high correlation between observed and predicted salinity across given fields, which then lends us the opportunity to take that to the regional scale. And here's where we've extracted values from individual fields then to go in more to the regional scale mapping. And then this is a salinity distribution map of that entire Bear River Basin within Cache Valley, about 45,000 irrigated acres. Where up toward the Idaho border, we're lower in salinity and getting more towards the commingle areas between the Little Bear and Blacksmith Fork rivers going into Cutler Reservoir. Down in the middle of the valley, the salinity gets increasingly higher. So what we're hoping to do is to be able to do these inventories throughout the state in the major river basins, and then have a baseline inventory that we can then use in modeling to say what's going to happen when we have changes in water distribution as climate change may affect the distribution of water. What happens is water allocation changes within a basin as we get increasing pressure on water resources going to municipal and industrial uses over agricultural uses, and get a handle as to what we can expect to be the future impact perhaps of changing salinity conditions within these basins on our agricultural, horticultural production throughout the state. So with